Hello and good evening to all of you. I hope all of you are doing well and all of you in good health. So, in today's class, we will be talking about an important concept of object-oriented paradigm that is called as inheritance. Now, inheritance is one of the most important features of object-oriented paradigm that enables a class to derive properties and characteristics from another class. Again, I'll repeat it. Inheritance is one of the most important features of object-oriented paradigm that enables a class to derive properties and characteristics from other class. Now in C++, it is possible to inherit attributes and methods from one class to another class. That is, it allows us to create a new class from an existing class or a set of existing classes. Now, the new class is called as the derived class, whereas the existing class or set of existing classes are called as base class or set of base classes. This implies a class can derive properties from one or more than one class. That is, a class can inherit data and functions from one or more than one base classes. So, to define a derived class, we use a class derivation list that specifies the base class or base classes. So, we can further state that in case of inheritance, there are two types of classes, namely the derived class or the child class, and the base class or the parent class. Now, derived class or child class is a class that tries to inherit properties from other classes, whereas parent class or base class is a class from where the properties are inherited. Now, alternatively, in some of the literatures, you may also find base class and derived class being referred to as superclass and subclass. So, base class is also called as superclass, whereas derived class is also called as subclass. Now let us try to understand what inheritance is capable of representing. Now inheritance is capable of representing is a relationship. So inheritance is and is a relationship. We use inheritance only if there exists is a relationship between different classes. Now for an example, a car is a vehicle, an orange is a fruit, a surgeon is a doctor, a dog is an animal. So these are examples of is a relationship. Now let us try to understand why do we actually need inheritance. Now let us consider an example. Let us consider there are three vehicles, bus, car and truck. Now for these three types of vehicles, the methods like get fuel amount, get capacity, get revenue are important functions. Now let us consider two different scenarios, one without inheritance and one with inheritance. Now first let us start with a scenario where we are not considering inheritance. So in this case, what we need to have is we need to have implementation of these three functions being separately done for bus, car, and truck. Again, I'll repeat it. So we are considering the first scenario without inheritance, wherein we need to have implementation of these three functions separately being done for bus, car, and truck. Now, this will not only lead to duplication of code, but it will also increase the chances of error and data redundancy. Moreover, it will non-optimally use computers' resources. So in order to prevent that or in order to avoid that, what we can rely on is we can rely on inheritance. Now, instead of creating three different classes in the first instance, let us create a class by the name vehicle, right? And have implementation of these three functions being done for the class vehicle. So once the implementation of the three functions are over for class vehicle, then let us derive class bus, car, and truck from the class vehicle. So in this situation, what we can avoid is we can avoid implementation of these three functions being separately done for bus, car, and truck. It will not only prevent duplication of code, but it will reduce the chances of errors and data redundancy. as well as it will optimally use computational resources, and moreover it is capable of promoting an important concept that is called as reusability. So reusability is the fundamental reliance of inheritance. So inheritance proposes or promotes reusability of code. So this is the reason why we need inheritance in a situation where there is a relationship. Now let us try to understand something about access control and inheritance. Now, a derived class can access all the non-private members of the base class. Now, this is a very important statement that all of you need to understand and remember. So, a derived class can access all the non-private members of the base class, which implies any base class member that you do not want the member of the derived class to access should be placed in the private section of the base class, right? Again, I'll repeat it. Any base class member that you do not want the members of the derived class to access, it should be placed in the private section of the base class, right? So this is very much important for all of us to understand. So a derived class can access only the non-private members of the base class. So in order to summarize that, here we have a very simple table. So here we have the access specifiers, we have public, protected, and private, and we have same class, derived class, and outside the class. Now members of the same class can access public, protected, and private members. Members of the derived class can access public and protected members only, where it cannot access the private members. Now outside the class, it can access the public member, but it cannot access the protected and the private member. So this is a table that tries to summarize the different types of access you can have. Again, I'll repeat it. Members of the same class can access public, protected, and private members. Members of the derived class can access only the public and the protected members. It cannot access the private members. And from outside the class, you can access only public member, but you cannot access the protected and the private member. Now let us try to understand various modes of inheritance, right? Various modes of inheritance basically refers to the mechanism using which you can derive new classes. So you can have public mode, you can have protected mode, and you can have private mode of inheritance. Now, let us try to understand what is public mode of inheritance. So if we derive a subclass from a public base class, please listen to me carefully. If we derive a subclass from a public base class, then the public members of the base class will become public in the derived class, and the protected members in the base class will become protected in the derived class. Okay, so if we derive a subclass from a public base class, then the public member of the base class will become public in the derived class, and the protected members of the base class will become protected in the derived class. So this is very much important for you to remember. And as we have already learned, we can access only the non-private members of the base class. Now likewise, in case if we go for protected mode of inheritance, so if we derive a subclass, from a protected base class, right? If we derive a subclass from a protected base class, then both the public and the protected member of the base class will become protected in the derived class. So this is very much important. So if we derive a subclass from a protected base class, then both the public member and the protected member of the base class will become protected in the derived class. Now the third mode of inheritance is called as protected mode of inheritance. So if we derive a subclass from a private mode of inheritance, so if we derive a subclass from private base class, then both public and protected member of the base class will become private in the derived class. So these are the three important modes of inheritance. So you have public mode of inheritance, you have protected mode of inheritance, you have private mode of inheritance. So let us again repeat it. So if we derive a subclass from a public base class, then the public member of the base class will become public in the derived class, and protected member of the base class will become protected in the derived class. Now, in case of protected mode of inheritance, if we derive a subclass from a protected base class, then both the public and the protected member of the base class will become protected member in the derived class. Now, likewise, if we go for private mode of inheritance, so if we derive a subclass from a private base class, then both the public and the protected member of the base class will become private in the derived class. So these are the three important modes of inheritance, using which you can inherit derived classes from the base class. Now, this is a very simple table that tries to summarize whatever we've discussed. So here we have base class member access specifier, we have public, protected, and private. So these are the access specifiers of the members in the base class. Now, types of inheritance, we have public, protected, and private. So when we go for public mode of inheritance, the public member will be public, the protected member will be protected, and private cannot be inherited, right? This is what we have learned till now. If you go for protected mode of inheritance, public will be protected, protected will be protected, and private cannot be inherited. Now, likewise, if you go for private mode of inheritance, then public will be private, protected will be private, and private cannot be inherited, right? So this is a very simple tabular representation that is capable of specifying the various modes of inheritance, right, which shows the base member access specifier and types of inheritance. So again, I'll repeat it. If you go for public mode of inheritance, public will be public, protected will be protected, and private cannot be inherited. If you go for protected mode of inheritance, then public will be protected, protected will be protected, and private cannot be inherited. Now, likewise, if you go for private mode of inheritance, then public will be private, protected will be private, and private cannot be inherited, so it's not accessible. So a derived class inherits all the base class methods with the following exceptions. So you have certain exceptions that you need to remember: constructor, destructors, and copy constructors of the base class, overloaded operators of base classes, and the friend function of the base class. So these are some of the exceptions, right? Some of the exceptions in case of inheritance. Now, there are different types of inheritance. You have single inheritance, you have multiple inheritance, you have hierarchical inheritance, you have multi-label inheritance, and you have hybrid inheritance, which is also called as virtual inheritance. Now, in today's class, what we have learned about is we have learned about what is inheritance, right? We have learned about what is the relationship that inheritance tries to exhibit. So we learned that inheritance is capable of exhibiting is a relationship where it tries to only represent whether there exists a user relationship between different classes. We have taken some examples as well, and we have talked about why do we need to have inheritance. So we have taken up an example, and we have taken up two different scenarios with and without inheritance, and we have seen what are the pros and cons. Now, likewise, we have also discussed about access control and inheritance. We have learned that a derived class can access only the non-private members of the base class, or it can access all the non-private members of the base class. So this is a very important statement that one needs to understand. And then we have summarized the access control with the help of a very simplified table, wherein we had the various labels of access from same class, derived class, and outside the class. And then we talked about different modes of inheritance. We discussed public mode of inheritance, we discussed private mode of inheritance, and we discussed protected mode of inheritance. And we've seen what would be the effect of the different modes of inheritance. And then we learned about some of the exceptions in case of inheritance. And we have learned about different types of inheritance. We've learned that there's a single inheritance, multiple inheritance, hierarchical inheritance, multi-label inheritance, and hybrid inheritance. So in the upcoming classes, we'll be talking about each of these types of inheritance. So thank you very much. Have a very nice day.